Okay, now we're set up for the final dimension of that bore. We'll run more like 1200 RPMs, and we'll get down manually, with more precise with the quill drive, but manually it'll be good enough to squish some stuff in there. You seem good. Oh, we'll make you closer. And this one will go. Yeah, that'll make noise. We're digging about 50 thousandths on the diameter. This one will go until I see the chips enlarging a little bit, because the geometry of that insert is not for flat bottoming. When the chip starts enlarging, it means that it reached the other one, the other depth. That's about it. That's good. Moving from the next hole. Unlocking the table. When you do those kinds of operations, you better lock the table. Okay, 250. We're 110. That's not bad. Okay, let's go. I'm raising the knee of the table. I'm not going with the quill. Raising the knee is more precise though. There it is. Using a smaller boring bar make it sing a little bit more. It's not as rigid as like a stout, twice the size boring bar. But the finish is a few notes written in the there we go. The other side, and I made it so we were going to be centered pretty well on this, because I want the holes to really like they're kind of bearing surfaces, so they're even. Okay, let's go. Give it a little tap again, making sure the parallel bars are in place, and we're going again now. Let's a little bit of WD-40. I'm cranking by hand, and that knee's heavy. Okay. If I'd be going a little slower, I wouldn't get that much singing. But 750. Okay, within 110, we're perfect. Oh, going in again. We're in the bottom. Chips are getting wider, so I'm reaching the other bore. Excellent. And that's it for that part. I'll show you the result of this. See, it's a pretty okay, now we got a good angle. It's a pretty flat bottom. You insert the tool, does a very nice job at bottoming flat, and boring bars got a little bit of an angle on the side there to reach so I can reach the bottom flat, so it doesn't make a rising, like a cup in the bottom. But so far that's pretty nicely done. Now we're doing the part that will hold the central pivot and the collets, and I want to make sure this part is rotating like within maybe 1,000 something for alignment on the horizontal plane. And I'm going to find out the center of this, and we're going to machine 2 slots that will be used to put up the the central pivot, the assembly. So this is running within I would say, oh boy, maybe around 1,000 of an inch, which is very acceptable. We'll find center and we'll start machining the 2 side slots on this. Finding center on the exterior diameter of this part, it's the same thing as finding internal diameter, and I am not centered at all. I mean, I'm kind of pretty off from there, but doesn't really matter. We'll go find the first edge for the brakes. That's it. So we're in Y0. Let's go to the other side. Okay, we're at 2.64, so makes it 1.32. Okay, we're going down to 1.32. Okay, we're there, and now we're going to do the other axis. Let's go for the first side. Okay. Just raking X0. Use the electric advance on the table a little bit more. Put that down. This is it. 2.641. That's not bad. One means 1.32. Let's go up center. Okay. Let's just make a. Yeah, we're matching with our late little dimple in the middle. Wow, that's nice. I'm pretty sure we're putting 1,000. Okay, that's centered. Okay, now let's try a simple way to make this slot in there without, going into tons of measurement. I'll make an approximation of what I need to remove from this this part there. I need to remove this. This comes out, and making a slot. I'm making a line further than what I need, and I'm going to cut in there arbitrary measure, less, less that one I need to take out, but just enough to be able to take measurements on each side. So I'm centered from the middle there, from the arrow, so I'll go there, take off a few, let's say maybe 100,000, take off 100,000 on this side, about just eyeballing, get some distance there on the height too, and then we take measurement and we see what we're left to get out, and starting from there we take it out. That will explain itself as we're going. I'm making cut here, like from the center. It's going to let me more than I need, but it's going to be 1 inch and 375 inches, and I'm going to go to the other side at the same symmetrical measurement, and I'll go down there maybe 3/8 of an inch, just eyeballing again. Let's get this there. It's a half inch, or that's a 13 millimeter end mill, and that's a two lips. We'll be running about 1300, 1400. And I'm going to lock that rotary head. Okay, let's bring this down about I don't know, 3/8 of an inch, and we'll be going right in there. And let's go about let's say 1400. Need to lubricate this probably a little bit, and I'm gonna be soaked with chips because looks like blood. Okay, I'm holding on the finished part, so I'm not going too harsh on it. Let's go to the other side. 1 inch and 375. Put in 1,000 or even half 1,000. Okay, now let's make some measurements. Plus a few thousands. I need in between those, those two. I need something like 2 inches and 15,000. So the measurement there is 2 inches and 237. So means I'm having to remove half of that on each side. It's 1 inch and 7,000, let's say. Minus, I still need to get 300 thousandths on each side. That was stupid. Oh bon, ça. Calisse, c'est en dessin. C'est bon. 2 points. Ok, on recommence. Ok. Here we have two inches, 237. So we need 2 inches and 15,000. 2 inches point 237 minus 2 inches point 015. That gives 222 thousandths of an inch total. So we have to divide that by 2, which is divided by 2 equals 111,000 on each side. So I'm already 1 inch and 375. 1 inch, 0.375 minus minus 0.111 equals 1.264. If I put my DRO at 1.264 on each side, then I'll be within 1,000 or something. I'm going to leave myself some room for finishing. Okay, let's go for this cut. Same depth. Okay, it's an easy cut, but I prefer easy than slipping or whatever. Okay, 1.260 on the other side. I'm leaving myself like 5 thousandths, 1.260. Same thing. So we should be left with what we need plus 10,000. That's perfect. And now we're going to depth. And to go to depth, we'll need to just deeper this. Okay, now as far as the depth is concerned, we're measuring the depth of what's already there. Okay. Got my big fingers in the way. Okay, we're at 309 thousandths deep in there so far, and we need 800,000. So I'll put the DRO at 309 minus, because we're going down, and let's go to make it almost 800,000. Let's say 790. We'll keep 10 thousandths for a finishing cut, and this will be exactly good. Let's go for a nice little cut. We'll go always easy. We're on finished part. Avoid to stop feeding, just feed constant, slow. I'm being sprayed by chips. Okay. Going to the other side, 1.260. Let's go in. Okay, we'll do a climb cutting for a few thousands, both directions. And that's it. Another part done. Exactly what we need. And as far as depth's concerned, within 5,000s, that's perfect. Now that part needs to be drilled there on each side to get the the holes that were the 1/4-20 to hold the central pivot and what goes with it. So I'll move the table, the rotary head, and we'll be back. Okay, we centered ourselves. You know, like axial wise and X and Y directions. I need to be 400,000 from this surface there to align the screws, and we're off by 400,000 from the middle. I already found the center of the part. I'm already installed, ready to go to the first screw, 400,000, and we're gonna start drilling. Okay, the next one is number 7 drill bit to make a 1/4-20 tap. I'm having problems with centering here. Okay, there we go. We'll be going down about 3/4 of an inch. There we go. And let's drive a tap in there. I'll put the machine in neutral and drive that by hand. Let's just start it. Avoid doing like I've already done. Press the wrong button, going the wrong direction, full speed. And that wasn't nice. There we go. This way, it's done safer. going 400,000 the other direction. Okay, so speed around 1000 RPM. Number 7 drill. Oh shit, I'll pick it up later. Nice little chamfer. It's a cleaner entry for the tap and also the screw after. Nicely done. Now we'll start the tap. Nice hole, and the other side will be the same thing as turning the table here, the rotary head, sorry, it's 40:1 ratio head, and easy, it's 20 turns on the handle, and we're exactly like 180 degrees around. We're 20 turns later, everything lines up super nice. And same thing again. Okay, this is what it looks like. I hope it focuses. And we'll be able to install the mounting, the central pivot all together. Now we got all the parts, and I think we're anxious to see what it does. I'm outside. This is still province of Quebec. I don't know, it's 18th today, I'm not sure. March 18th. Still cold, like -7, -8 in the sun. Windy a little bit, so I got a coat, I got gloves and hat, and on top of the tripod. This is it. I'll give you close-ups in a few minutes, but I'll show you a little bit where I'm at. This is going to take place of the camera support in the front, which will be hinged, and it won't react exactly like it should, but it's holding the bottom bar in place. Okay, this is my counterweight system, temporary, and this goes up, this goes down. If I take the weight out, it's moving and revolves, and the feeling like it's just very nice, soft, smooth feeling. The bushings, just like the UHMW bushings that I put all over the place, which you'll see later, are doing a fantastic job at doing this. So the central pivot is all done, except a few cosmetic things in there, but it's functional. Now the platform at the end has to be done, and the weighing system. But see, you're going up like now the the tape doesn't do the right function, but you're going up. You can go about 45-60 degrees. I can put this a little bit more forward and we'll go further up, or I can take some material out there too if I wanted to. But this is like getting on its way pretty well done. That's about, I'd say, about 4 feet there. And it's adjustable, so if we get like a smaller area, restrained places, we can also just diminish the length or just change the ratio here. And the weight system, I'll probably make something that slides on top of there, so so something adjustable, so to make the balance easy. I need to make a wheel there to just tie this up. It's just holding now, but I think that's giving off a fantastic feeling so far. I'm happy with how smooth it is, up and down, and all around. It goes 360 degrees easy, like it's no problem at all. And like the height there, if you put the camera up there, you'll be, I'm 5'10", 5'11", and with my hand there, it's almost like 7 feet and something. You can have the camera about over 7 feet high with a standard tripod, and if you raise the neck there, I mean, you can go any much, as much as this will give, about maybe this more. And also, if you get a better fixture, better tripod or whatever, you can go like sky's the limit. So far, I'm happy with it. I'll give you close-ups of the different parts, though maybe you'd like that. Here we have the central pivot, and with the height limiter, that's, swiveling around. It goes like 360 degrees, very smooth. I'm almost just feather pushing on this, and reacts pretty nice. I can, with the collets I made here, I can move the bar forward and backward. The same thing with the bottom bar, adjust for the angle if I need to, adjust for length, and that shouldn't be a problem. And the base pivot there, just like goes, this part move regarding to this part moves regarding to this one. And the only thing, maybe if we need to make it go like higher, we can take some material off this bushing there that holds the this here. But besides that, it's going about 45, 50 degrees high now. It could go a little higher, but that's not too bad. There we go. That's so I'm there so far, and I keep on working on this. What I need to do now is the platform here that will hold the camera at the the following angle, keep it like level with the ground, whatever height we're up to, and so far I'm proud of it. So that's it for now.